Hello,
Hello, hello.
we're back.
Yeah,
So,
yeah,
yeah,
yeah. That's like
hopefully
the
you're recovered.
that's the shortest Linux terminal crash course ever. So it's like it can be a bit like okay, what is happening here? Like kind of a
Yeah,
situation, and but it gets better. Like once you
yeah,
get accustomed to it, and but if you still have problems with it, don't hesitate to put the stuff into the notes because we'll be using that example as a stepping stone for the next things. So do check that if you can run the code that we
yeah,
put there. There's an example
yeah,
solution now. Like yeah, sorry about not having an example solution ready. We have been on a we're moving some of the materials around, but now there's an example solution uh, there in the notes, so you can try it out if you had problems. Uh, yeah, over here.
okay. Here,
Yeah,
I guess.
yes, there's the. You can try that one out if you still haven't managed to
Yeah,
do it. But don't worry about this too much. Like don't worry about like if it is seems super complicated. Like the idea is that we will get more like you will get more accustomed to the terminal once we start writing the scripts and everything like that, and we start using the terminal more and more. But
yeah,
now, should we move towards like this is like we've been talking about the terminal, how to use the terminal, and yeah, where's the HPC or like where is the computing stuff? But this is needed for us to be able to actually do the HPC stuff. So Richard, maybe we should
yeah,
talk about the next step, which is the queuing system. So let's view again uh, our
yeah.
cluster here. So
So,
what is the queue?
yeah. Actually, I could grab my demo materials from one of the HPC Kitchen material videos and go and give a live demo here, but I'm not prepared for that. So
Yeah,
let's see. So in short, when you have hundreds of computers and thousands or hundreds of thousands or millions of processors available, how do you know what each person can use and for how long? So Slurm is the thing that takes all the requests. So you might say, I have this job where I want 10 processors and 200 gigabytes of memory, and it will find the resources and tell you where you can run it. Or someone might come and say, I need between 1,000 and 1,000,000 processors with 4 gigabytes of memory per processor. And it will find what's available, wait for them to be there, and then give them to you and let your thing run. All in the background without you having to be there and wait for it to happen.
yeah, and this queue manager is called Slurm. So whenever we are talking about Slurm, the name sounds strange, and it is, but that's what it is. But
Yeah.
whenever we're talking about Slurm, we mean the queue manager. And many clusters, or some clusters use different queue managers, but at least here in Finland, I think everybody's using Slurm. CSC is using Slurm. We're using Slurm. It just rolls out of your tongue once you get used to the word.
Yeah.
But yeah, like once you know how to reserve resources with Slurm, you can use it in various other clusters as well. So once you know the parameters that the Slurm takes, you can get resources. So if we
Yeah.
look at the picture, we can see that we are most of the time we are spending our time in the login node, or maybe you have reserved like an interactive session with the on demand, but anyways you're in some interactive session and you want to run the stuff in in the actual like CPU nodes in the other computers. So should we now check how can
Yeah.
you reserve those resources?
Yeah. Oh, actually, can you scroll down? I think there's a nice picture here that shows the box
Sure.
that's scheduled. Uh, there. Yeah.
Yeah.
So whenever you are scheduling a job, it's basically rectangle that's the number of CPUs, the amount of memory, and the time. And then optionally, you can throw in some number of GPUs there. So that's the kind of thing. So we need to define what these boxes are. And
And
then
usually,
the
the
rest.
good way of starting to like approximate the boxes is like compare them to your own computer. So if your computer
Mm-hmm.
has like 4 CPUs, you might want to request 4 CPUs. If your computer
Yeah.
has like 16 gigabytes of memory or 8 gigabytes of memory, you
Yeah.
want take the same one. And if you have if you program runs on your laptop for hour, you might want to request something like 2 hours.
Yeah.
So
Mm-hmm.
so you have this kind of like size of what is your job, what does it need for it to run, and then you can estimate the first guess what is the size of the job, and then you can refine the guess later on.
Yeah.
So Richard, what happens when you like tell Slurm these requests? What does it do?
So you tell it a request, and you tell it what the requests are, and then the batch script. So basically, what will be run. And then it adds it to a database of everything that's requested. And then it stores it. It sorts it by priority. So most clusters, actually, is it most clusters in Finland and the world now, use something called fair share. So
I think
basically, the
vast majority.
most, yeah. So it's not a strict queue where the first person to submit something goes first. Instead, it's like the first person to, well, it takes all the requests, and the more you run, the lower your priority goes. So that it sort of tries to balance it out so everyone gets about the same amount of stuff. So it's something like CSC where there's a limited number of billing units. It might take that into account, but at least in our university, it's designed to be relatively equal.
And if we check the resources, so we also already mentioned that there's like the time memory, CPUs and GPUs, and for each of these, there's usually some arguments or parameters that are listed over here. We'll go through them when we are actually going to be submitting the jobs, but you can always come back and reference, let's say, this page or the relevant tutorial pages to figure out what were the magic flags that Slurm needed to know about these resources.
Yeah.
There's also on some other clusters, there's other parameters you might need to tell. Like for example, in CSC, you need to tell which account you're using, like which is the one who will be built. And in some cases, you need to also give partitions. So often the cluster, if you look at the cluster here, the cluster is split into different partitions based on what sort of job there needs to be running or what sort of architecture they have. For example, the GPU nodes are often separated into their own partitions. So sometimes you need to give this information as well when you're submitting a job. So in these cases, please refer to your own cluster's documentation, what magic flags you need to add in order to get like this job running on the compute nodes. Like usually it's like partition and then the name of a partition.
Yeah. Is there anything else here, or should we go on to the examples?
I think probably, yeah, I would say, do we have anything in the
Yeah.
chat? Any good questions?
No, nothing we need to. There
Yeah,
is one question: how to decide how many resources to allocate for the job. And
yeah,
actually, yeah, maybe we can briefly mention that. I know
yeah.
Simo,
So
you made a page on this once.
yes, there's you can check. There's this quick like guide on the job size, um, like
Yeah,
what is
I
the
pasted it in the
program
notes
size.
there.
Yeah, and you can check that,
Yeah,
and basically it's like like I said, like you can often compare it to your own computer, like what are the resources over there, and often you can use the, let's say, if you don't know if your program uses multiple processors, you can run it on your own computer and check the process manager in your machine. There's hints in the guide, like you can check how many processes are being used by the program and then determine from that like how big is the program. But usually what you usually give these resources, you don't want to give like exactly the limit what the program uses. You want to give it a bit leeway so that it doesn't get like like so it doesn't get throttled or anything like that. So basically, like if your program uses one CPU, then you usually want to have it one CPU. If it uses like 8 gigabytes of memory, you might want to give it like 10, just to have a bit of like option of going a bit over. And if it takes like an hour, you usually give it like hour and a half. So you give it a bit leeway that if it runs slower this day, then it will still finish. And usually it goes like you first guess some number. If it crashes, like if it is too small, then you just increase the number. If it's too big, we will talk about job monitoring tomorrow. So there we will talk about how you can get the numbers out after the job has run, like how much it actually used, and then you can like limit it. And you usually want the submission to be quite close to the size of the box, because then the queue knows that okay, you like this is the amount of things needed by the job, so you can like it can fit it best into the queue, so then you won't get like bad priority because the job you're requesting more than you actually use. But should we start running?
Let's go on.